what I'm about to do is just kind of do the big picture of what you're going to have to do in this lab. Like, I'm not going to make a table of 15 to 30 data points. I'm going to just zero in on the high spot and the low spot, which would be one of those 15 to 30 data points. And I'm fine with 15. There's no reason you have to do 30. It doesn't make you a better person if you do 30 data points. Now, do you get that if you pick a city that's really close to the equator, you're not going to see much of a wave because they get the same amount of sunlight all year long? Okay? So if I were you, I'd pick a city that's kind of like where we are. And you can pick Minneapolis. That's not illegal. And you can take our data. And if you even want to drill it down to Minnetonka, awesome. These websites tell you exactly how much daylight we had and what the longest day was and when it was. One of the hardest things will be, oh, it happened on June 21st was the longest day. What number was that? Was that day 175? Get what I mean? June something was the 100 and something day of the year. Okay, so you'll have to figure that out. And again, these websites will help you do that if you look through them. And in fact, just Googling and just asking Google, you can probably get it to tell you, June. Once you figure out it's June 17th, well, figure out which day of the year that is. I'm going to go with, let me imagine for a moment that was our high spot was on June 21st, and that was the 175th day. On day 175, if I were you, I'd write this down. This is not the exact numbers, but I'm going to show you what I would do if I had the exact numbers. If on day 175 we had 13.5 hours of sun, that would be our high spot. Up until that, it was not that high, and then after that, it gets lower, right? And then it goes the other way, where there's a low spot. What day might that be? Well, do you guys know what time of year we get the lowest amount of sun? Yeah, in December, so it's got to be 330 is probably the beginning of September, because it goes to 365, right? Okay, so let's say it's on day 340 of the year. We get a really low amount of sun. Let's say it's 9.5 hours of sun. So how do you write a sinusoidal for that? Again, I gave a whole lesson on it yesterday, and if you're a genius, you can pick it up from what I'm about to tell you. You got to find the midline, the line that runs right down the middle. And think about that, that's the y values, midline. So that's exactly between 9.5 and 13.5. What you do is you average those two numbers. Or they're smart and go, oh, there's a difference of 4, so this must be 2 up from 9.5, which would make it 11.5. So 11.5 is the midline. Well, so what? How does that affect your sine or cosine graph? We always use cosine, and if you watch the video from yesterday, you'll understand why we always use cosine. So cosine of, and then there's something, and then there's x minus something, and then there's plus something. Those 4 boxes, those are the numbers you got to figure out. Everybody's equation will start with y equals. Everybody's going to use cosine. And then it's just these 4 numbers. And I'll show you how you would figure them out. Not giving you much explanation, of course. So this one is the amplitude. And so that one would be from 11.5 to 13.5, which is 2. That's how much it goes up from the midline up. That's what you always do to figure out the amplitude of something, is go from the midline up. All right, next. This is period is 2 pi over b. That's just an equation that's always true. The period is 2 pi over b. So then, what's our period? This amount of time is the amount of time it took to get halfway to a full period. Do you get going from a high to a low is not a full period? From a high to a low is like partway there. You got to go from a high to another high. That is a full period. Okay, so then if I say it's 175 and 340, has anybody actually already done the math on this? All right, then I will grab my calculator and figure out what is 340 minus 175. 165, and then it's not 165 though. Got to times it by 2. 2 times 165. Why are you timesing by 2, Surver? Because that's only from a high to a low, and that's not a complete cycle. So I times it by 2. So that would be 300, and shouldn't it be about 365? Yeah, but it's not exactly 365. Weirdly, but true. All right, so in this case, again, I made up these numbers. They totally came off the top of my head. These are not real numbers. But it's going to be kind of a good walkthrough. I didn't want to use real numbers that you could then just say, well, I did the lab already. I just happened to use the same numbers you did. So these are fake numbers. So 2 times 6 is 12 plus 1 is 13. And 2 minus 3. That's 330, is that right? Yay. Okay, so 330 is the period. It should really be more close to 365. But, so 330 goes here. 330 equals 2 pi over b. So then b equals 2 pi over 330. All right, next, the reason that we use cosine and not sine is because at some point, you got to say that this graph is shifted over. The odds of you having your graph start exactly on the day that you had the highest amount of sunlight, if you had started your graph exactly right here, well, then it wouldn't have any shift. Okay, but in the real world, you're not going to get that lucky that the teacher sends you out to do the tide lab on the exact moment that you hit the high tide or the highest amount of sunlight. So that means we got to shift it. So then how far do we shift it? The x value is how far over it's shifted. Because that's how far over the peak is. It's not at 0. It's not right at 0. It's 175 over from that. This is how far 175 is. Okay, then the plus. That's really easy. The midline, that's how far this graph got moved up. That goes in there, 11.5. Yay. That's basically the equation for a mythical city that had its peak amount of sunlight on the 175th day and its lowest amount of sunlight on the 340th day. I think you get the idea. Do you get Alaska's equation to be different than ours? Have you ever, anybody actually been to Alaska? Cool. What time of year did you go?
I went in the summer.
Summer? How about you?
I think the summer.
Probably the summer. Not many people go there in the winter because, you know, it's a little bit cold and snowy and whatever. But in the summer, you get tons of light. Do you remember it being weirdly light out? Or were you too young to remember this?
No, I went like 2 summers ago. So it like at nighttime it got dark, but not completely dark.
So from my experience, when I went up there in July, we saw, like, basically it turned into like twilight, and then, like you said, it never really got dark. It was almost like it was twilight all evening. It might have been a tiny period where it was completely dark, but it was like twilight almost all the time when evening would have happened. So I was up at 11, and I remember saying to myself, okay, I feel like the sun just set at 11 p.m. So anyway, their equation would be quite different than ours. Because why? Because they get a lot higher wave of sunlight in the summer and then a lot less in the winter. So their amplitude is much higher than ours would be. And ours amplitude is much higher than anybody who lives on the equator, because there it's really doesn't change much. Do you remember when you lived in Australia? Do you remember enough? Because I know you're really young. How young were you?
9 when I
Okay. Do you have any recollection of the days being longer or shorter or anything?
Yeah.
So was it more like Alaska or more like here or more like the equator?
I would say it's closer to the equator.
Okay.
We had in our summer months we had really long days, but we could be outside for a long time. But I don't ever.
And your summer months are not June, July, August, right?
Right. It's December, January, February.
December, January, February, which makes it a great place to visit from the United States, right? Because if you're like, hey, in January it's really cold here, it would be the middle of summer. So it's one of my dreams. I would love to be able to teach remotely. And, you know, you should go for your dreams. So there's a chance that next year I'll be teaching remotely. If I am, I will be teaching from New Zealand for a while. What does that mean about what time of day I'll be teaching?
You're going to be a night owl.
Yes. My son's in Japan right now, which is pretty much the other side of the world, right? So he takes a class that's being given in the United States right now. And so he has to start the class at 9 p.m. and finish the class at 5 a.m.
Oh, that's a long class.
Yeah, 8 hours of, it's like an 8-hour day. He's in the military, so he's got his 8-hour work day. They have the class all day. They have a break for lunch, which is very logical to him because it'll be at like 3 a.m. Anyway, so my point, that would be so cool to be able to be in and just experience summer in New Zealand or Australia. You'll have to convince me about Australia versus New Zealand. I don't know. I got to go see where the Lord of the Rings was filmed, I think. That'd be pretty cool. All right, so anyway, this is a lab. And I pretty much am done with it, except what would have been wrong on my lab, I didn't have 15 data points, of which I would have picked out the high and the low spot. You know what I mean? You obviously don't pick random 15 numbers. Pick the numbers that include a high spot and a low spot. And then it'll be kind of nice because you'll be able to see that your numbers end up right on your curve. Then you'll actually graph yours on the Desmos. And then it'll end up working out that your data points end up pretty darn close to your equation. It won't be perfect because your equations can't be perfect, but it'll end up, you'll have data points and your graph running almost through them. And this is what I would have typed in to Desmos. Okay, any questions? I know for some of you that was pretty intense because you didn't get yesterday's lesson. So again, I have the video is up and waiting for you to relearn that stuff. Your main job between today and Thursday is the lab, because it'll also help you with one of your or two of your test questions are kind of like what the lab is like. So when is your test? Your test is not on Thursday. We felt like that would have been pushing it too much, especially with the craziness happening of Chauvin trial and all that stuff. So bottom line, the test is not Thursday. And then it couldn't be Friday either because Friday's a Pep Fest day, so you're going to have a really short day. You have class, but it'll be really short, so you can't do the test that day. So that pushes it into next week. And then Monday of the following week is weird. I think Monday is your mass day, I think. So then that means it can't be Monday. And we can't give you a test on Tuesday after a 4-day weekend, so then all of a sudden the test is Wednesday. It's crazy, but that's the way it goes. So yeah, I'm sure you won't cry too much. You have plenty of time to review for it, okay? So we had to either push you super hard and then see a lot of people not do so well, or give you lots of cush time to review. But then if you just not review, that would be bad. This is your chance to get a really good grade on this test by having time to practice. All right, so what else are we doing today? I am giving you a quiz, and I know some people are still getting, and don't stress, not like in the 85% category. This is, or in the 90 in this class. This is in the 10% category. This is just a homework quiz. It's on graphing, and I'm going to have you graph some things on a different Notability doc than you've been taking notes on. Get a nice, clean, blank Notability doc. I'm going to give you one warm-up question, and then I'm going to give you 3 more that count, and we'll grade those. You're going to give yourself a score on the top out of 10, And I want you to just really be real with yourself on how good are you at graphing trig functions right now. Okay? And if that's bad, it turns out to be a bad score, then that's just kind of a heads up that you better study this then. There's plenty of worksheet problems and keys for those worksheet problems that you could use to get ready for the test, which is coming up next week about this time, about a week from now. Okay, then here's that first one. Now, those of you that are lucky enough to actually be able to get in to Schoology, you'll see this thing. One of the files in the folder for today looks like this. And so I am going to put that, I'm just going to write those on my screen because the kids at home can't see it if I do it the other way. So here's the first one. Y equals 3 cosine of 3x minus pi. Just graph that. Don't worry about how many periods. I just had everybody just do 1 period of each. But watch out for that on the test. If they ask you for 2 periods of something, you got to graph 2 periods, which basically means repeat it. So everybody just graph this one for practice. We'll go through it, make sure you're on track, and then I'll tell you the other 3 problems. I'm going to pause the video for a second here. So this first one's mostly just to get your feet under you and make sure you're not completely lost on graphing normal cosine. So there's a normal cosine graph, and it goes to 2 pi. In the middle is pi. Back here's pi over 2. And I like to go 1 pi over 2, 2 pi over 2, 3 pi over 2. And 2 pi is, of course, the same as 4 pi over 2. Then I like to number this with a 1, and down here at -1. Okay, that's normal cosine. You should have changed the 1 and the -1 to 3 and -3. Next, if you can factor it, you should. And you got x minus pi over 3. And you might be thinking, well, how am I supposed to shift that to the right, pi over 3? Well, you can't see pi over 3 yet. But when you get done with this 3 here, this 3 is all over the place, obviously, so I'll circle it. This 3 here is going to make everything get multiplied by 1/3. And all of a sudden, you'll see a place that is pi over 3. So you'll know how far that is. This is pi over 6. I like to say 1 pi over 6. 2 pi over 6, hint, hint, synonymous with pi over 3. That's how far you're supposed to have moved it. 2 marks. Let's finish this. 1 pi over 6, 2 pi over 6, 3 pi over 6, and 4 pi over 6. I'm aware you can reduce those. No, I don't require you to reduce those because to me they flow so nicely. And then they help you number it. When you have to move this thing to the right, then you're supposed to number all the spots where you moved it. So if you moved it right like you were supposed to, 2 marks, well then I need 2 more marks on here. And they're going to be, continuing my numbering, 5 pi over 6 and 6 pi over 6, aka pi. Now, to actually move it over, I'm going to draw this in blue, and it starts here. It's got its low spot here, and it ends up here, and that kind of helps me like just big picture it. There. It was not perfect, but the blue one is pretty much your answer. Was there any questions about how I did that? Because you're about to be quizzed for the rest of the hour, and then we'll grade it at the end of the hour. Do you have any other things that you like, I don't get how you did this or that? Or what if we had to do this? Okay, here's a couple what ifs. What if you had to move the whole thing up 1? You would physically move it up 1. You would not just renumber the labels. Just like we physically moved it to the right, we did not try to relabel when we moved the black one to the blue one. We did not try to just relabel that. That would make it too confusing to understand. Yes?
Do you do the stretches before or after?
It's a good question. You kind of go from left to right. I don't know if you noticed, but I did this vertical stretch first, and that was the first number. Then the next thing you do is renumber based on that B term. Okay? Then we shifted it. Because when you shift it, you have to shift it based on the new numbering. You get what I'm saying? So this is not mathematically really correct, but it happens to work in this case. If you go from left to right, you'll at least do your renumbering before you're shifting. That's the main thing, is the inside there. Always do the renumbering, the divide by a number on the horizontal, all those horizontal numbers. Get that part done first, then shift it. Okay, so here's the 3 that you're going to actually be graded on then in your homework, which you will then Dropbox it into the thing called graph. Actually, I'm not going to say the name of the Dropbox, so I might get it wrong, but there's a Dropbox for today and this little quiz. Okay, so here's question 2. Think of it as number 1, you got completely right because I helped you. Number 2, graph y equals -2 cosecant of pi x, and then I'm leaving a space here to make it really clear that that's not on the inside. That +4, that's on the outside. All right. You may want to write these down because that's going to be off the screen in a second here. Here's question 3. Y equals 2 tangent of x plus pi over 2. And question 4. Cotangent of x plus 3 pi over 2 minus 1 on the outside. Okay, now those are really small. If you can get the document to load, it is a PDF. You could do it that way. But just make sure that you're ready to grade this, and we'll hand it in at the end of the hour. I'm going to pause the video again while you work on it, and I'll resume it when I'm grading it. You start with 10 out of 10, and then if you make any of these mistakes, you lose a point. Nope. I'm just going to have this one Dropbox once. Thanks for asking. All right, so here's your cosecant graph. First of all, it rides on the back of sine. So I'm going to draw my sine graph in here, and hopefully that's what you did too. You can erase it back out at the end. That would make sense. But to start with, you'd want the sine graph in there. 2 pi, pi, pi over 2, 1 pi over 2, 2 pi over 2, 3 pi over 2, and 2 pi. And this is 1, and this is -1, and all of that isn't even cosecant. Cosecant is the one riding on its back right here. Like that and like that. Asymptotes here and there and at 0, 0. Okay, now what does it have to do? Well, first thing, this 1 changes to a 2 and a -2, and that is your first point. Did you remember to change these numbers? Super easy. If you forgot changing those numbers, you lose a point. If you did change those numbers, you still got a 10 out of 10 going. All right, next thing I wanted you to check for is just the nature of the fact these are U shapes, one going up and one going down like this. If you have that right, you've got 1 point. If you forgot and you just graphed sine by accident and didn't even put the cosecant on it, you lost a point. Okay, next point. We have to divide everything by pi because there's a b term of pi. So each of these is divided by pi. That means this comes out to 2. This comes out to 3 over 2. This comes out to 1. And this comes out to 1/2. It's basically like the x-axis loses its pi because you divided everything by pi. That's worth 1 point. And the last one's really messy to try to check, so I'm not even going to grade it, but I hope you know it would have moved up 4. Okay? You would physically move it up 4. You would not renumber it. Yes?
Would you flip it because of the negative sign?
Oh, and the flipping. I forgot the flipping, and that is a point. Thank you. I remembered it last hour, but I forgot it this hour. So 1 down and 1 up then instead of 1 up and 1 down. So they're flipped, and as I said before, they're moved. But the moved part, I didn't grade. The flipped part, I did grade. 1 point off if you forgot to flip them.
Wait, so it is a negative? Because on the PDF, it doesn't look like there is.
It's
really small. It's really hard to see.
It's 1 point you lift. There was a negative. Okay, on to number 3. On number 3, you're looking for tangent. Well, here's the tangent graph. It goes between these two things, and it goes like that. You also need pi over 2 and negative pi over 2. Okay, that's normal tangent. It also needs a 1 here and a negative 1 here. Why? Because those are the spots that you'll have to renumber when they put a 2 in here. So now we make that a 2 and a negative 2. Again, 1 point for remembering to change those y labels. Next, we have to shift this thing. It left pi over 2. Now here's how far pi over 2 is. From here to here, that is pi over 2. So when this thing shifts to the left, pi over 2, it now will be here. And its asymptotes will follow it. The red one is the final answer. It is shifted to the left, pi over 2. That's another 1 point if you by accident shifted it to the right or up or somewhere else. Okay? Now to keep our lives simple, that's all we're going to grade. I know there was a 4th problem, but we're running out of time, and you have to still wipe down your desks and all that stuff. So I will show you what it should have looked like so you can know if you would have done it right. Here's the cosine or cotangent graph, and it goes from up to down, and it would be pi right there. The tricky part of this one is trying to show that it moved down 1. So you'd have to try to take this spot that's sort of the middle of that curve and move it down 1. And you also needed to move it left 3 pi over 2. Well, here's the next asymptote, and that would be at negative pi. So that isn't even far enough. You'd have to move it quite a ways to the left to get it to be left 3 pi over 2. All right. Very difficult to grade, partially why I didn't grade that one. Okay, so just don't stress on that one if you generally understand it now. Now you've got either a perfect 10 out of 10 if you didn't get any wrong in there. If so, would you please drop box that with a 10 out of 10 on it? If you got one wrong, or let's say you construed one to be half wrong, 9.5 out of 10 is acceptable. Put your scores on the top. Drop box it. Can somebody tell me the name of the drop box? Hold on. Practice quiz?
Practice trig graph.
Practice trig graphing. Quiz? Or just practice trig graphing? Practice trig graphing is the name. All right, I got to save this before my iPad dies.